Because, of course, unfortunately, it is not testable experimentally. But this grand unification issue or ambition is something that has driven a lot of people, and that's what he's about to, I believe, talk about. We'll see. So I wanted to give you that little background there. So third piece of circumstantial evidence for supersymmetry comes from the notion of grand unification. One of the puzzling features of nature's four forces is the huge range in their intrinsic strengths. The electromagnetic force has a less than 1% of the strength of the strong force, so electromagnetism is less strong than the strong force. The weak force is some 1,000 times feebler than that, and the gravitational force is some 100 million billion, 10 to the minus 35, in other words, times weaker still. So gravitation is the weakest, then weak nuclear force, then electromagnetism, and the strongest is the strong nuclear force. So just the variety here and the fact that these four forces are just so so what's the word? Different from each other. Scales are different, strengths are different. What is up with that? What is a theory that can explain all four? Why do we need four different types of explanations for four different things? Why are they even four different things? Why are there four fundamental forces? We kind of know some things about each one. You know, gravitation is given to us by general theory of relativity after Newtonian mechanics explained it for many years. I think it might have even been a couple of centuries, actually, if I'm doing my math correctly. But at the same time, general relativity does not explain electromagnetism, weak nuclear force, and strong nuclear force. So what is up with that? And particle physics explains strong nuclear force and weak nuclear force, but it cannot explain gravitation. So what is up with that? Why are there these four different things? Why are they so different from each other? Why are the strengths so different? You know, that's part of this. That is a broader, bigger question that we ponder here. Okay. So, following the path-breaking and ultimately Nobel Prize-winning work of Glashow, Salam, and Weinberg, that established a deep connection between the electromagnetic and weak forces. So, by the way, there is some connection between the electromagnetic force and the weak force. Even though you have to try kind of hard to find this connection, there is a connection. And in fact, I will go as far to say before he says it, because I kind of know it already, there is somewhat of a unification between the three fundamental forces of electromagnetism, strong nuclear force, and weak nuclear force. Those three are still kinda, sorta able to be unified. If you operate in different energy regimes, you can kinda, sorta unify them. But, and this but is a very big but, these three that I just now mentioned are not unified with gravitation, even to this date. String theory is a candidate, but even to this date, we don't believe, at least I don't know, that it's really unified. So that's going to be a big issue, but he's saying that at least electromagnetic and weak forces were kind of unified by these people, Weinberg, Salam, Glashow, and they got a Nobel Prize for it. So it's very important that there was some progress in unifying at least some of it. You know, in 1974, Glashow, together with his Harvard colleague Howard Georgi, suggested that an analogous connection might be forged with the strong force. Their work, which proposed a grand unification of three of the four forces, so grand unification in quotes, because if if you unify only three of the four things, then we will call it a grand unification and do the air quotes, because a true grand